For links to the audio and video versions of the Industrial Software Podcast, as well as a newsletter sign up, you can always head to ManufactureSoft.com. You can also reach out by email to contact@ManufactureSoft.com. Thanks, and let's get into the show. Hello, and welcome to another episode of the Industrial Software Podcast. I have today joining us Sam Clements. Thanks for joining us, Sam.
Yeah, thanks for having me on. Good to be here. Happy to talk all things tech and all things wireless.
Beautiful. So first off, just to start off, why don't you just give our audience a quick overview of what it is that you do and kind of what your specialty is?
Yeah, absolutely. Thanks. So I work here in the States at a large VAR. In fact, I guess we're considered a global VAR. But I look after the mobility practice here, primarily focused on Wi-Fi technologies, but we cover everything from license frequency technologies to non-Wi-Fi technologies and the like. So really, if it's connecting something without wires, I'm interested in it.
So it's interesting. I've been trying to learn a little bit more about wireless in particular in industrial applications, and anyone I come across who's prominent or well-known in the industry, you go to their Twitter bio or something like that. So you go to some industries and they'll say that what companies they're at and
Sure.
what school they went to or something like that. But you go to someone in industrial wireless and it's just acronym soup.
Yes.
And so I thought we could just quick go over like what those are and what their significance is and why you listed the ones that you listed and what they mean. So yours are CWNE number 101, CCIE, CCIE Advisory Council. Okay, so what are these acronyms and what do they signify?
Yeah, so because we like to be very precise individuals, they're actually initialisms, not acronyms.
Got it.
But
Thank you.
the initialisms for CCIE is Cisco Certified Internetworking Expert, which is a Cisco-specific certification. It's their expert level certification, and mine is focused on the wireless technologies. I also sit on the Cisco Global Board of Advisors at their external group for the certification and training programs. So those are the two sort of CCIE ones, and then I forget what the other one was. CWNE. Oh, CWNE. Yeah, the Certified Wireless Networking Expert, which is from the CWNP program, the Certified Wireless Networking Professional program, and the expert level certification is the top end of that one as well. They focus on vendor neutral wireless technologies. You go talk to an infrastructure manufacturer, you go talk to a client manufacturer, you're going to get their spin on it. The CWNP organization is all about the standards, 802.11 standards, 802.15.4 standards, right? They're more about the underlying technology and the infrastructure without a vendor-specific spin on it. And so of the two, one is highly vendor-specific, the other one is vendor-neutral.
Now it is vendor agnostic, but the C is still Cisco?
No, on the CWNE stands for certified. So Certified
Okay.
Wireless Networking Expert, yeah.
And I have to imagine there is a tug of war between the big players and the vendor agnostic. Like I know I follow most closely browser standards, and that's the dynamic that plays out. You have Google throwing their weight around with the Chrome spec and stuff like that within the vendor agnostic groups. And I have to imagine the same thing happens in this space.
To a lesser degree, I think if you look at the Wi-Fi industry and the Wi-Fi community as a whole, and specifically sort of the experts of that industry, there are, I think, around 300 CWNEs globally. And that number is probably fairly close to the Cisco certified, to the CCIE wireless certification track as well. And so you're not talking about tens of thousands of people who are going out and getting these expert level certifications. And so there is probably some room for some competition, I suppose. But the CWNP program as a vendor neutral certification program really does have that space pretty well locked up. And they do a really, really good job at it. And it really is sort of that difference between the IEEE, right, the propeller heads who are building the spec, the Wi-Fi Alliance who's doing the certification of the devices, and then an organization like the CWNP sort of bringing it all together saying, we understand the technology and we understand how this works in the industry, and here's what makes it all go without the vendor spin.
Right. So whenever I deep dive into like a particular niche related to anything in industrial software, basically,
Sure.
There tend to be standards and regulations and stuff like that, and you kind of have to reverse engineer what they are from who the advisors and the vendors are that are most prominent.
Absolutely.
For example, I met someone with robotics that talked to me about the proximity towards robots and what speeds are rated and how you can quantify that and things like that. Sure. Do you have any advice for someone who's going niche to niche and needs to quickly identify what the regulations are that are most relevant to that niche, or is it just Google soup and handshakes as I've been doing?
Yeah, I think you've got it. It's that brute force. Get to know people in the industry and find out who's saying what and when and where, and eventually, hopefully, you get some commonality. And I think I think there's less of an echo chamber problem, maybe at least in the wireless space where that occurs. You ask 1,000 Wi-Fi folks who are professionals getting paid doing this as their day job, hey, who are the people who really represent you from a certifications perspective? CWMP really does race to the top. But again, I realize you asked sort of about other industries, and I've seen that occur where you step in and you ask 10 different people who are doing the same thing, and they're all going to give you a different answer. That tends to not be the case in the Wi-Fi industry. The standard is fairly well fleshed out. It's fairly well standalone. And then we also have these other organizations that sort of work off of each other and play off each other. The Wi-Fi Alliance is well known. So a lot of these bodies are very, very, very well entrenched. Unfortunately, they don't always represent the enterprise space. They don't always represent manufacturing. They don't always represent those big, large campus deployment styles. They tend to be focused on Soho type of things. When you go to Best Buy or wherever you go nowadays and you buy a router and it says I'm a Wi-Fi compatible router, that's the Wi-Fi Alliance's job, is to do that logo and that interoperability testing, and that does carry over in the enterprise space. And so it's rare that you have an industry that has such a close touch to the consumers through one product and then a close touch to the enterprise through another product using the same certification track. So
okay. So let's talk about big picture industrial wireless. I know, there's right. So cliff notes of it. So you have Ethernet, and that's probably used more and where possible for various reasons. And then you have wireless as a way of connecting everything.
Of course.
What's the breakdown there? Yeah, I mean, like what % do you think of industrial applications are wireless today? Is it like, I know it's like an overgeneralization, but like kind of where are we on that curve?
Yeah, if I look at a traditional manufacturing facility and I say how many of your connected devices how many devices with MAC addresses are connected by wired or by wireless, the overwhelming majority of them tend to be wired connected. Your PLC control devices, right? Those super low latency sensitive applications where you're talking 2 to 3 millisecond latency requirements could be the difference between life and death. Those are very, very real, very tangible applications. And yeah, a lot of organizations do still run, Profinet, or they'll run PRP for redundant links, or they'll do any number of technologies on the wired side for that low latency component of it. But on the wireless side of the house, the technology is built specifically around collision avoidance, not collision detection, wherein you sort of start by assuming that you're going to incur latency, and that tends to run contrary to what a lot of manufacturer or PLC controlled type of applications want, need, or could use. And so it tends to be very highly specialized. But the things that are Wi-Fi connected in a plant, they tend to be those highly mobile assets, and they tend to be incredibly valuable to moving the manufacturing chain along. Hey, right connection methodology for the right device at the right time in the right place. There's no such thing as one connection technology for everything everywhere. And that's really the lesson. Yeah, you can't just go and do one. Manufacturing in particular, man, you have all sorts of stuff, and not even just wired or Wi-Fi. You have license frequency stuff. You have extremely small cell stuff, personal area network type of things. It just runs the gamut.
So, given that that's kind of the default would be to do it wired, and then if and when there is an appropriate application, let's go wireless. Do you think that there's any element of actually, with the advances that have happened, you could have done it all wireless, but you just made the conservative choice.
Well,
right.
yeah.
Do you think there is an element of that at play?
There's not an element of it at play. I would say that's the overarching theme behind manufacturing.
Same as software then.
Yeah, you bet. Well, it's one thing when you get into a conversation with somebody and they're concerned about life and limb safety requirements, and we see that not just in manufacturing. We see it in entertainment. We see it in a variety of places where you're dealing with harnesses and rigging and that personal safety communications, whether it's just audible communications or whether it's IP-based communication to a handset or to a device that you're carrying. People get really squirrely really fast when you start saying, "Hey, if this doesn't work, you could lose an arm." And so sure. So I think that there have been a large number of advances in the technology. Directly answering your question, Wi-Fi today is not Wi-Fi as it was 20 years ago. It is significantly more reliable, significantly more robust, significantly better built to handle things like interference. Unfortunately, just because Wi-Fi 6 or Wi-Fi 6E or Wi-Fi 7 or the latest 802.11 standard comes out doesn't mean that your manufacturing environment magically gets to adopt all of that right away. This backwards compatibility is a real pain in the rear, and there are plenty of manufacturing environments who say, yeah, I've got this automated guided vehicle that's been driving around my plant moving things from point A to point B, and it's using the same technology as it was deployed 10 years ago. And so your network is only as strong as your weakest link, and that 10-year-old box that's moving around in your infrastructure means that you may not get all that reliability, resiliency stuff that comes with the improved Wi-Fi features and technologies that come with. If you're building something greenfield, piece of cake, you're going to buy it all new anyway. Go for it. But
okay.
Backwards compatibility is a real pain.
I definitely do want to come back and talk to what advancements have really been big changers. But first, so it's interesting that you frequently bring up life and limb safety issues as related to wireless communication, because that's counterintuitive to me, because anything that needs to have single digit millisecond response time and never ever fail, I would think would be done on device. And so there would be some kind of something local to that device that ensures the safety, and which would be a separate concern from the device communicating with the network. I'm assuming, that has to happen a lot of that happens on device. But what are the specific types of things that are life and limb safety issues that would be network reliant?
Sure. So look at entertainment, or look at on vehicle controlled. We'll just take a step back from manufacturing. The entertainment industry has a lot of parallels to those extremely low latency type of applications, largely because automated guided vehicles on entertainment tracks are very, very PLC controlled. They're very, very safety oriented. And so go to a theme park.
Do you mean roller coasters?
Yeah, including
I was like, what's an automated vehicle that's for entertainment? A roller coaster?
So look, I've been to Universal Studios and been on a ride where there is no track. You're literally in a vehicle with tires that is moving by itself. It's not on a rail. It has its own power source. It has its own motors. It has its own cameras, video, the whole 9 yards. And somebody has to maintain and manage that. What happens if a person who's riding the ride jumps out of the vehicle? Somebody somewhere has to hit the stop button, and it's not going to be the driver on the vehicle, because there is no driver on the vehicle. Look at Disneyland, the Indiana Jones ride, right? They pulled the tracks out of that a long time ago. You still have to maintain that connection to that vehicle as it moves through the infrastructure, whether that's a patron-induced safety issue, somebody jumps out of the vehicle, or whether it's a failure on vehicle of a PLC or of a battery or of a track or of a whatever. You have to be able to respond to those things in sub-millisecond response times, and a lot of times, at least in the Wi-Fi world, the problem isn't necessarily just runtime communication. It's that when that vehicle moves from access point 1 to access point 2, that tends to induce latency, and you're trying to mitigate that roaming latency as that device moves throughout your environment.
Now, in that specific use case, I have to imagine there's a whole class of products that are to bridge that gap between when you go from one access point to another access point, there's some kind of a centralized thing that negotiates that and like minimizes it and controls it during that gap and things like that. Is there a word
you would
for
think,
what that would be?
Yeah, non-existent. Yeah, wouldn't that be awesome? Unfortunately, in the Wi-Fi world, we have to deal with this pesky thing called the 802.11 standard. And there is no coordinated function for controlling that roaming handoff. All roaming logic happens at the client. And so you have to then deal with mitigation techniques where you have to deal with clients that may not do things that you want to do, but you still have to maintain a link while that client is doing something. That's where technologies like PRP come in, where you have parallel redundant paths, where you have a wireless client on the front of the vehicle and a wireless client on the back of the vehicle, so that when it moves from scene to scene, that first client can roam. And while that client is roaming, the infrastructure is firing 2 frames or 2 packets at that vehicle over redundant links. And whichever one arrives first is the one that gets consumed. And if that first adapter is in the middle of roaming, then we always have that second link up and operational until that first link comes up that can take over, and then that second adapter can then roam gracefully. And so just because you have Wi-Fi as a low latency technology doesn't mean that you can't do things that are sort of additional to the standard, like parallel redundant paths. But yeah, at the end of the day, as far as Wi-Fi is concerned, the standard exists for a reason, and sometimes that doesn't really align well with manufacturing.
So just to double click on one specific part of what you just said, the 802.11 standard specifies what the client needs to be responsible for in nitty-gritty situations like that?
No, and that's part of the problem, is that it leaves that logic up to the client. And so it's sort of up to the client in an undefined state. Hey, Mr. Client Manufacturer, Intel or Broadcom or Raylink or whomever, right? Oh, this is where you differentiate. Your application may have different SNR requirements. It may have different RSSI requirements. It may have different tolerances for different noise floor. It may have different roaming algorithms. But that uniqueness to the client is very, very, very specific to the client. And not all clients behave the same. And that is, well, I guess if it wasn't for clients, wouldn't our life be a whole lot easier? But this really is the embodiment of, every client is different. And that's really where the challenge comes in. When you build a Wi-Fi network, it's not for the infrastructure. When you build a Wi-Fi network, it's for the client. And you have to build that infrastructure how that client wants to behave in your environment.
I first came across you in an interview that you did at Tech Field Day. And one of the things that was called out in the interview, it was a vendor who's got a solution that isn't Wi-Fi. And one of the criticisms of, like Wi-Fi networks as they exist today in industrial settings is that they're suboptimal and there's a decent amount of downtime. And they called out that there could be up to 30% downtime of the Wi-Fi network. Is that the case? And if so, why is that the case?
No. And yes. Okay. As always, of course.
So maybe
depends,
that's like
right?
worst edge case scenario.
Well, it really comes back to the protocol in place. And I hate to sort of ratchet it back to the IEEE, but the 802.11 standard that was built is a very, very extremely polite protocol. It was meant to be a polite protocol. It was meant so that when you deployed Wi-Fi in downtown New York City in your little, 800 square foot condo surrounded by 50 other people who all have Wi-Fi, that on some level your Wi-Fi continues to function. It's meant to built to be tolerant of interference because it runs in an unlicensed frequency, which everybody has access to. Everybody has access to it, which means everybody plays in it. Therefore, you need to be able to have a sandbox where you can be cooperative from a protocol perspective. LTE technologies are not built like that. LTE technologies are not built to share the spectrum with peers. So when you have a Verizon or an AT&T service, they have a clean slice of spectrum that they have leased for all intents and purposes from the FCC, and your LTE service for AT&T rides on whatever slice of spectrum it is, and there is no interference. And if there is interference, then the FCC steps in and says, I'm going to mitigate that interference for you. Right? There's no protocol-centric interference mitigation built into it. And that's really one of the things that makes LTE shine above things like Wi-Fi, is because one is very, very polite, one is very, very, very prescriptive. And so licensed frequency versus unlicensed frequency, sort of problem number one. Problem number 2 is in the Wi-Fi world, we have to contend for the medium when we want to speak. We have to go through this listen before talk algorithm. We have to put our ear to the ground and say, hey, is there noise in the air? If there is noise in the air, here's all the rules I have to follow. And the person who speaks in the Wi-Fi world, whether it's an AP or a client or another AP or another client, they're all treated as even. And they all contend equally for the medium, and there is no single truth or single air traffic control, if you will, that says, hey, you over there, you speak. Hey, now I'm going to speak. Hey, now you over there, you speak. In the license frequency world, all of our transmissions, all of our transmit opportunities all happen at the same clock cycle, and so they can all happen simultaneously. In the license frequency world, we get GPS synchronization, so that we get clock synchronization, so that everybody around us knows from a clock perspective when it is time to transmit. That doesn't occur in the Wi-Fi world. When you set up Wi-Fi at your house, you didn't say, hey, here's my GPS receiver so that I can get sub-millisecond clock synchronization time so that I can be in sync with my neighbors who don't do the same thing. That's really at its core, that's the problem with Wi-Fi, and that's the benefit of LTE or 5G or 4G solutions, is that air traffic control, or not even really air traffic control, it's those synchronized transmissions where every client talks at the same time, and then they shut up, and then every client talks at the same time, and then they shut up, and they can get away with that because of synchronization.
Okay, so let's talk about all of the discrete solutions that there are for wireless communication. So we've got
there's more than what we could. There's more than
right.
Yeah. It's a laundry list. Yeah.
So the big hitters, I would think, would be exactly that: Wi-Fi, 5G, Zigbee, LoRaWAN. Am I correct in that?
Different technologies for different use cases. Yeah, you wouldn't deploy Wi-Fi to replace a LoRaWAN network. But yeah, primarily your low latency, high bandwidth applications, generally speaking, are going to be either Wi-Fi or they're going to be LTE-based technologies.
No,
4G or 5G.
Forgive my ignorance. Does LTE include 5G and
4G and 5G?
4G, and so that's all just like
all flavors of LTE.
What I think of as things that are relevant in telephony, are all fall under LTE.
Correct.
Okay. So tons of hype that I've seen about 5G specifically.
Yeah.
To what extent is it a game changer?
Well, I
or is this a sensitive question in Wi-Fi circles?
No, it is and it isn't. It is because we see a lot of the 5G players going, hey, replace your Wi-Fi network with 5G. The messaging around it in true marketing form tends to pit one against the other. And the reality is they're not. They're not. They're really meant to be complementary technologies, the right technology for the right use case at the right time for the right price point. One of the things about private LTE or CBRS services here in the States, right? So if you're an international listener, you would be considering private LTE. Here in the States, we just call it CBRS, is you get the benefits of that LTE protocol, which is good. But of course, you have to have radios that are built for it. You have to have ideally a use case and an application for it, because that can be considered expensive. When you start operating in those CBRS frequencies, you have to start dealing with license allocations. In the Wi-Fi world, you don't. When you go to Best Buy and buy a router, you don't have to go online to the FCC and register where your address is at and register what frequencies you're going to be using and blah, because all of that happens in the unlicensed frequencies here in the world. In the LTE space, whether it's private LTE or public LTE from a carrier or whatever, you still have to have that license, that frequency coordination. And there are tiers of frequency coordination. There's a free tier where you are sharing it with everybody else, and then there's a paid tier, if you will. And that paid tier can be extremely expensive. You're talking millions of dollars in a given zip code just to bring radios on for your guaranteed slice of spectrum. And
is that PAL?
That's correct. Yeah, that's the priority access licenses. Yeah, as opposed to the general access licenses or the GAAs. So general versus priority, right? And a
PAL license is localized to what geographically? To
oh
a
my
county
goodness!
Or a city,
yeah,
or even just to the plot of land you own?
No, it's. I believe the last time I read it was PALs are issued in a given zip code, And so there's tons of docs because the way FCC does license allocation is different than the way the EU does them, and so on and so forth. So it's going to be up to your regulatory domain. But yes, the last time I checked, PAL allocations are done per zip code.
So since it's different in different
regulatory domains,
in different nations,
yeah.
Do you end up with a lot of vendors that are nation specific?
Yeah. I wouldn't say necessarily the entirety of the vendor is sort of country specific, but you'll end up with a solution from a provider that has a SKU that is sold here in the States, and then they will have a rest of the world SKU. Or something like that, or they'll have a country-specific SKU, or something where they've got a PID that's been defined on the device that says, "Hey, I'm being operated in Russia, and therefore the Russia rules are this channel, this power, this whatever." Yeah, that's not uncommon at all.
Now, something I've heard to kind of set aside the concerns about, needing a PAL or not, a PAL or not,
yeah,
right, is that indoors in your own facility you have free reign. Is that a thing? So you can basically just like do whatever you want within the spectrum within your own walls. Now, I don't know if like hardware wise and like spectrum wise, what you do in your building is physically contained somehow. I would think it still affects beyond your walls to some extent.
Yeah,
so how does that all
a lot of misunderstanding about how that works. We as private citizens, we as corporate entities do not own spectrum. Period. End of story. There is no ownership of the spectrum with the exception of the FCC here in the States, right? That's why you have regulatory bodies, which means that regardless of you're being in a bunker or 50 feet underground, you from a legalities perspective cannot turn on a radio outside of an unlicensed frequency without permission to do so. And yes, you can go to jail. If you break FCC rules, they have field vans that drive around and keep an eye on these things. If people file a complaint against you, there are very, very real fines that can occur. I have run into a handful of situations like that where I've had to involve the FCC, and the FCC does indeed come out, knock on your door, and say, you really, really don't want to go to jail. You might want to stop doing that.
Where do CB radios
it's rare
fall in that? Because it seems to be Wild West for whatever that is.
So Citizens Band is again an approval by the FCC to say
that makes sense.
Citizens Band. There you go. There's the CB and CBRS, right? Citizens Band Radio Service or Citizens
cool.
Band. Yeah, right. Yeah, so it all comes together. Yeah, it just so happens to be that some of those frequencies were being reused in the CBRS world. And so, the point is that if you are operating in a frequency, the FCC is involved some way or another. If you are operating Wi-Fi, the FCC is involved because they have granted all U.S. citizens access to an unlicensed spectrum. Right? There's a clause 15 that says, hey, you here in the States, you can do anything that you want to in these spectrums in these channels, as long as you abide by some power restrictions and some channel restrictions for us. FCC says otherwise, go ahead. Now, something like CBRS or these lightly licensed frequencies where you may have to go and get casual permission to do something may be entirely different than going to a full-on licensed frequency application where you just literally have to go to the FCC and apply for a license, pay for it, and then you don't pay for it for ownership, you pay for it so that you have access to that in a given calendar year or something along those lines. And then every duration you have to go back to them and re-up. I was talking to a large sports organization that was looking to do on the field communications with coaches, and they wanted to avoid unlicensed frequencies because their coach communication system was considered to be high priority. They didn't want it to be susceptible to jammers. They didn't want to have somebody coming into the stadium with a thing in their pocket that could interfere. They didn't want to have neighbors. They wanted that comfort level of saying, hey, I've got clean spectrum to myself and I'm willing to pay for it. And that's really the upshot, is if you're willing to pay for it,
and they can't do
then
something
you get all
digital and
sorts of
just
great stuff.
encrypt on both ends?
So you can do something digital encrypt on both ends, but how do you gain access to the medium if somebody else is already transmitting, chewing up all of your spectral energy?
Mm-hmm.
And so that's the mitigation technology. That's precisely the point of all of this. Yeah.
Just to make sure my understanding is correct. So the more casual CBRS Not like, well, that's a GAA license. Am I correct?
Yeah, so they're the GAA licenses, yep, which are the general. Oh my goodness, I should know the initials. General access, GAA, general licenses.
Got it.
Yeah. But again, even those
and-
require phone home to the FCC, so that the FCC maintains track of that in that automated frequency coordination database, another set of initials, the AFC database, so that when you come up on a GAA license and your neighbor comes up on a GAA license, hopefully they're in different slices of the spectrum, so you don't fight.
Okay, so and then if you're using the GAA license and you need something to negotiate, like what channels you're on, and that's prescribed by the FCC.
The FCC. Yep. The FCC
what is
has
that
a
hardware
big phone.
and like do they sell you that? Do they like
So
how do you what is that hardware and who sells it?
It's a federal service, right? So the AFC service is really just a federal phone home service, and your infrastructure must comply with FCC mandates for sale in the U.S. That's what that little FCC logo is on the back of whatever it is radio that you're buying. And the device manufacturer has to build that such that it phones home to the FCC along with GPS coordinates, whatever, and it will not bring up the radio unless it has completed that phone home procedure. That's part of
so
that
device
operation.
That would be Cisco or Meraki or Aruba or Mist.
No, that's anything really AFC driven. And in this side of the conversation, we're talking about CBRS
AFC.
or private LTE, automated frequency coordination. So your CBRS or private LTE solutions would do that. Now, 6 gigahertz in the unlicensed space, especially with external antennas, high-powered, standard power, things along those lines, will also require AFC. But today's Wi-Fi networks, as they exist right now at this moment of time, do not require any FCC coordination beyond doing DFS checks. And DFS checks are essentially checking for incumbents. And if you hear an incumbent, you got to get out. And if you don't hear an incumbent, you can use the channel.
So when your AFC is going on and you're finding channels and stuff, do you ever end up without a seat at the table?
I have asked that question hundreds
wirelessly?
of times, and I get the dance every time I ask that question. It's my understanding that yes, once channels are run out and there's no channel available, then what else would you be left being issued? Now, I don't know that firsthand. That's one of the challenges I have with this entire private LTE CBRS conversation, specifically around low latency, high bandwidth applications in manufacturing, is if there are questions around GAA and the insistences that you should migrate to PAL for critical infrastructure uses, then that jumping to a PAL, you just tacked $1 million per site onto your deployment per year.
Now, just to double check, when you buy a PAL, you pay the government, correct?
The FCC. Yeah,
There's
you go to
nothing
auction.
private related in that transaction.
Well, you can go to a clearinghouse. There are organizations like, pick on a big organization like Charter, right? I think Charter went through this last auction for PAL licenses, and they scooped up $1 billion worth of licenses, whatever. But as a carrier, they do expect to turn around and resell those licenses or those frequency access back to consumers on some level. And so
Consumers
per PAL,
being industrial
or
companies.
us or you or just us common folks or enterprises. Yeah, the whole nine yards. It's not a. You bet they do. Which means that whatever they paid per PAL, you're paying a marked up price on top of it.
Okay.
And so it's fairly. In fact, I'm sure I've got the math around here somewhere. But yeah, it's. In fact, I do have it right here at my fingertips. So Dish Network bought 5,492 PALs at a total cost of, $905,
right?
Yeah, no, their per PAL cost
change
was $166,000 per PAL. And then if you go down in quantity and you buy Comcast bought 830 PALs at a unit cost of $551,000 each. That's $458 million. T-Mobile bought 8 of them for $5.5 million, which is a per PAL cost of almost $700,000.
That's okay. Here's a super random question. This is really putting you. Okay, what about like places where the U.S. government doesn't have jurisdiction, in the contiguous 48, like Native people's land?
Yeah, good question. I'm not actually sure what the clause is for spectral management on for example, First Nations land, but it is not unheard of to get FCC exemptions for. Now, I don't know that I can answer that one, but I can answer. There, you definitely can get FCC exemptions for lab environments, for bringing up radios in a controlled fashion, for development purposes. For I run CBRS here at the house, and I have an exemption to run CBRS here at the house. It's not a proper AFC filing, although there is a proper AFC filing. When CBRS was coming online and those AFC databases were not up and operational, yeah, you can go to the FCC and get an exemption for a period of time in order to run on a particular channel at a particular power level, and then bring your own technology, right? Whatever it is you're running, you're sort of blessed by the FCC. Yeah, First Nations land, I don't know. That's one I'm going to have to look into.
All right, so let's back the truck up for a second. You're doing it at your house? What's going on?
Oh, yeah. Well, yeah. Sorry. Yeah.
Is it for testing and for your own like professional? Okay.
Yeah. Technology.
Is that common in the industry?
No. Well, I guess I see in the Wi-Fi world, it's very, very common for people to have home labs, because Wi-Fi isn't really something that you can, unlike software development, or even a large number of network technologies, or even, collaboration technologies. There's not a lot of fundamental requirement to have something in practice that you have to touch and feel. A lot of times those things can be emulated, run in a VM, or run in a sandbox, or run in a whatever. But Wi-Fi, you if you want to measure from the radio to the client, you have to have that in space, and you have to have something tangible that does transmitting and receiving. So I think, in the Wi-Fi world, labs tend to be a bit more common than they do in other technologies. It just so happens to be that, here I happen to also touch other technologies like CBRS or other lightly licensed frequencies, or even full-on licensed frequencies.
Is there the concept in the space of like a remote test lab that you could like rent by the hour? So like in front-end web development, there's this thing, Browser Stack, where you basically can just like tunnel into any OS and any browser from all of history. So you don't have to set it all up locally and get your VMs all set and stuff like that. Like, can you rent out a facility and remotely try out whatever it is you want to try out? Or is that like not practical because you want to see and touch the physical hardware as you're testing the stuff you're testing?
Yeah, it tends to not be practical. I would say that the answer to that is probably yes and no. Yes, manufacturers will absolutely invite you to come to their executive briefing centers, and they'll invite you into their labs, and they'll invite you to take a look at the thing they're trying to sell you. But if you are a manufacturer and you're concerned about how this 2-ton automated guided vehicle is going to be moving from point A to point B as it connects to whatever infrastructure is in place, it is kind of hard to pick that vehicle up and move it to a test lab just to see it go from point A to point B. These manufacturing networks tend to be highly bespoke based on the environment that they're in, and that's a very, very real world problem. How do you pilot these things out and get confidence and get comfortable with them without actually seeing it and touching it with your own two hands? Yeah, it's hard to keep vendors honest sometimes.
Okay, so let's take the case of industrial 5G gets rolled out at a facility, and they're all in on it, and they want to connect everything to it. I would have to assume that, like, okay, if you have a Wi-Fi network, it's a local area network, and all of your devices on premise are all connected to some kind of a central on-prem hub where things are controlled and whatever. Now, if you move to an industrial 5G situation, that kind of like spoken wheel or like entry and then mesh dynamic, would it flip to every device goes directly to the cloud? And is there a name for that? Am I describing something that exists?
Yeah, it's
a paradigm shift.
Well, so yes and no, right? Because when we talk about 5G technologies, most of us are worried about the thing that's in our hand, and we look at 5G technologies as being the entry point to the cloud, right? It's the thing that we carry with us. And if I am doing 5G in my pocket, I'm not doing 5G to my home network. I'm doing 5G to the internet. In enterprise 5G use cases, CBRS private LTE. No, you wouldn't necessarily send that out to the cloud to hairpin it back. You would do local termination of that traffic, either at the eNodeB, at the AP, on premises or at your EPC or enhanced packet core on premises, you would deploy something that brings your radios together and your data plane traffic together to a centralized termination point at the infrastructure, and that then becomes the drop-off point, ideally in your core somewhere, right, without going to the cloud. That's one of the really, really compelling differentiators between a public 5G offering from a Verizon or an AT&T or a Sprint and a private 5G offering that really doesn't focus on voice services or text services or voicemail services. They focus on data. They focus on bits and bytes, and it's that data that gets terminated locally. And that strategy is very, very important to manufacturing-centric 5G, private 5G worlds. No doubt about it.
Since that structure seems to me to be a one-to-one map between how industrial Wi-Fi works and how industrial 5G works.
Yeah. Very close.
Do they sell solutions that are like, well, it's one like hub system, and you can spider off of it with Wi-Fi, or you can spider off of it with 5G, have at it, do whichever one you want?
Yeah, so, it's a good philosophical question, because we as network engineers, we look at, the network as being the entity, your traditional core distribution access layer, your traditional management plane, data plane, control plane functionality within inside of those boxes. And when you deploy core routers and distribution layer switches and PoE and, wired connectivity to PLCs and all those things, the network is really on premises. And it's really the thing that you are attaching either your Wi-Fi network to, or your private CBRS network to, or your private 5G network to, with the intention of connecting to some server somewhere, ideally on premises or in your own private cloud somewhere. Why do you need to talk to that vehicle? Well, generally speaking, it's because there's some sort of SAP system or some sort of manufacturing control system or something that says, hey, in order to get a tire to go out the door, I need to have raw materials come in. They need to be converted into strips, and they need to go around a mold. They need to go into an oven and bake, and then they need to go into curing. There's a system or an inventory tracking or a production manufacturing system that keeps track of that. And if your goal is to talk to that system, then everything needs to stay as close to that system as possible. Yeah, hairpinning out to the cloud just to come back and talk to some manufacturing inventory control system is just dumb.
Couldn't there be some use cases though that make that like practical? Like,
of course, yeah, of course, yeah.
You want to build all of your, not hairpinning back, but just doing everything in the cloud and never coming back.
Yeah, wouldn't that be awesome? I still think that low latency and cloud today are pretty mutually exclusive. I can't get a network connection here at my house that doesn't have better than 60 milliseconds latency out to the internet. Well, how's that going to work on your PLC controller that requires 2 millisecond latency? You have to have some logic on site to deal with those runtime decisions that these vehicles are making or that your manufacturing requirements rely on. That doesn't mean that the broad
on one sense,
stuff
I agree
can't.
with you, but also there's so many companies investing in cloud gaming right now.
Yeah, sure.
That really is like the ultimate test of low latency in the cloud.
Sure.
And that's kind of like the more dynamic that I'm envisioning.
Well,
I don't know if the technological case for doing things this way is as strong as the business case. Like, if you can convince manufacturers to do this dynamic where everything happens in the cloud and it never gets back on site, you're gonna make a whole boatload of money and you're gonna own the world. And so so even though the technological argument for it might not be that sound, the business case being so sound makes me believe that it's just going to happen.
Oh boy, yeah, that's a whole big old big old can of worms there. There's a couple of things that you said. The business use case, which I'm not entirely sure exists in the manufacturing world. The cloud is just a fancy term for somebody else's computer. You still have to pay for it, and if you're paying OpEx for it, that may look good on your books, but your ROI on that is not as perfect of a panacea as the cloud manufacturers might like you to think. But when we talk about broad adoption of low latency cloud applications, that's a phenomenal use case, right? That's a wonderful world that we would like to drive to. But where do you see low latency deployments happen? Well, you see those happen in your Google Fiber deployments, or wherever AT&T has 2.5 gig to the house, something along those lines. Downtown, large residential areas. Where do you see manufacturing? Out in the middle of Montana. out in the middle of Des Moines, Iowa. Those are not really bastions of low latency, high speed connectivity. Yeah, esports, e-gaming, low latency cloud applications are wonderful if you live in those metro environments where you have access to that type of technology. The reality is many of these manufacturing plants are still out on T1s, where you're talking about a 1.5 meg internet connection that they're paying thousands of dollars a month for, just to have a connection to the cloud, just so that they can get email. Yeah, it doesn't make sense in those situations, not at all.
That being said, I've also heard that called out as one of the use cases for 5G is last mile, where you would do fiber in city. How good it is? How good
it's going to
is
save
it
us all.
that?
Yeah, it's going to save us all. Yeah, sure. It's great if you're a telco. Right? It's great if you're Verizon and you've got a 5G PAL that you just paid $1 million for in a zip code, and you can get 5 millisecond latency out to a thing that's your router with a cellular modem in it or something along those lines. Yeah, that's awesome. Don't think it's cheaper. There's still an ROI cost to it. You still have to understand what it is you're paying for and what your bandwidth concerns are. And that's not always a slam dunk conversation, not by any stretch.
And
of the
there
imagination.
you probably for sure 100% do have to buy a PAL, which changes.
No.
Right?
In that instance, remember, you're treating Verizon as an ISP.
Okay.
So public 5G services from a carrier where the carrier has purchased the PAL. Yeah. And you are then turning around and writing your services on top of their 5G services, public
so
5G
you're still
versus
downstream
private.
of that increased cost.
Yeah. Okay. And you wouldn't do public 5G in CBRS with a PAL license. You would do public 5G in license frequency with carriers. You wouldn't necessarily go and say, "Hey, I'm a tire manufacturer. I'm going to go into the middle of Montana and buy a PAL and then deploy CBRS in this zip code from my carrier building." That is, 30 miles down the road. I'm going to put up a big antenna and I'm going to do CBRS between there and my manufacturing facility just to reduce that last mile latency. Invariably, that's not where the latency comes in. The latency comes in getting connection out to that colo. And so, yeah, it's kind of hard to virtualize radios. It's kind of hard to put radios in data centers and connect to them when they're hundreds of miles away. You still have to have, the physics behind getting energy from point A to point B, and then you can deal with latency concerns on top of that.
Okay, so let's go back to what you said is the reality of what's happening, which is, there's one hub and then the local network spidering off of that.
You're talking about in facility.
Right. Whoever owns that hub has a tremendous position of power to use that as a wedge to sell other things. So anything that could happen at that point of contact, they can do partnerships and sell. I see a future where your wireless setup and your networking and your everything is done for free. Just so that they can basically do an app store right at that point of contact. Am I describing Cisco except they don't do it for free? And or like, is this thing that I'm envisioning that seems kind of obvious? Like that point is so valuable to own that they will do anything. They will like roll out the red carpet for your facility to get you onto their network so they can own that point. Is that true?
Boy, yes and no. I don't distill it down to a single tangible point of entry, but we do see behavior like that out of carriers, where at least we used to see behavior like that out of carriers, where they would come in and say, "Hey, we're going to deploy a DAS system for a distributed antenna system for you. You've got good 4G coverage outdoor. You've got terrible 4G coverage indoor. We're going to deploy a DAS with a receiver outdoor, and we're going to replicate that indoor. And oh, by the way, we're not going to charge you for it because you're just going to get good Verizon service. You're going to be pro Verizon at that point." Well, they backed off of that considerably, largely because when organizations try and go and they try and lock up that frequency, that's what your enterprise is ultimately giving control up. When you have a carrier that comes in and says, "Hey, AT&T wants to come in and give you free Wi-Fi," isn't that great? Yeah, what they don't tell you is that when AT&T comes in and gives you free Wi-Fi, if you as an enterprise want to change something on that Wi-Fi, you want to deploy .1x authentication, you want to increase security, you want to change a channel, you want to do anything. Oh, sorry, that's a change order. Give me $10,000. I'll go ahead and flip the widget for you. Oh, sorry, that's a change order. Give me another. The ROI for that ongoing maintenance of that infrastructure, it can be huge. And that's one of the reasons why carriers have stopped doing that. And they started embracing things like open roaming technologies where you can do cellular offloading on Wi-Fi networks. And they're really relying more on the enterprise's infrastructure, with the carrier acting as the coordinated point of authentication, if you will. If I walk into an airport and I look down at my phone and I'm already, or a Lowe's or a Home Depot here in the States, hardware stores, I look down at my phone and I'm already on the Wi-Fi. I didn't click anything. I didn't go to settings. I didn't say yes. I didn't do anything at all. But my phone looked for an AT&T Wi-Fi network that was hidden in the Lowe's network and said, I identify this Lowe's network as an AT&T network. Therefore, I'm going to do WPA2 Enterprise .1x authentication using ePSIM of my device automatically onto the network. That automatic secure cell offload reduces the burden on the 5G network, puts the burden onto the enterprise Wi-Fi network, and it happens transparently to the end user. Now Lowe's owns that traffic, right? Because now your endpoint is directly attached to a Lowe's infrastructure. Your IP address comes from Lowe's. Your internet transport comes from Lowe's. Your content filtering comes from Lowe's. Your DNS comes from Lowe's. It's no longer about the carrier control over the device. The carrier just said, yep, he's an AT&T device, good to go, hands that off to Lowe's or any other open roaming network, right? The Disney's network or La Quinta's network or whomever's. And then now that enterprise ultimately owns that traffic and is responsible for securing it and then getting it out to the internet. I'm not entirely sure I answered your question, but I think I talked a lot.
It's a little different than what I was kind of like. Well, so I guess let's change gears a little bit to like a tangible example. Okay, so let's talk about the case that I have a product that I've made for industrial applications. Let's say specifically, I want to use cameras to do analytics. Okay, so like you set up a camera and you can do detection of various things. You can get analytics on how your production's going without having to actually hook up with any of the hardware. This is actually something I've heard called out as like, would be cool. Yeah. So I go around to manufacturers and I say, hey, I have a way that you can do analytics without changing any of your stuff. You just use cameras. Now, all of those cameras need to connect to something somehow.
That's correct.
Do I leave it up to the manufacturers how they're going to connect that? Is it Wi-Fi? Is it 5G? Is it what is it? Zigbee or whatever? Yeah. Or do I, as part of the product that I design, solve this for them and also sell them the networking solution?
It is the age-old question, and spectrum is a precious resource for us. And so if you're deploying a radio, that radio consumes spectrum. And if you're consuming spectrum, nobody else can consume spectrum at the same time. And so you would typically, in a good and an ideal enterprise organization, you would have a frequency coordinator who says something like, hey, your solution comes in and it's going to run on 900 megahertz. Cool, I see nothing running in 900 megahertz that could interfere with you. Thumbs up, go ahead. Or they may say, sorry, no more radios in my manufacturing facility. If you want to come in, you need to run on the infrastructure that we already have in place today, that we've already invested in. And that could be Wi-Fi, it could be LTE, it could be private LTE, heck, it could be just an Ethernet handoff. Invariably, though, you don't want to hang on to that analytics data in a vacuum. Right, that's no good to anybody. You don't, if you go to a tire manufacturing plant and say, cool, I'm going to point a camera at something and it's all going to go to the cloud. And in order for you to do something with it, you got to log into this portal and look at an event. That's sort of dumb. Why would you have analytics if you're not intending to hook it into a manufacturing system of some sort? And that network connection or that point of connection is usually Ethernet. Usually just a straight up network handoff from a Cat6 cable.
So just plan for the constraint that whatever it is going to need to be able to be hardwired.
It all depends on the customer. Yeah, there are plenty of customers who just say, yeah, I've got a convenience, or in a video analytics environment, that's not really what I consider a low latency, high bandwidth application. There's no PLCs, and right, you're just doing image analytics over and over and over again, and you can do that on box. You can do it in the cloud.
All you got to do is get the image.
To somewhere, and you're sort of good to go. Or frankly, you don't even need to do that, right? With some of these endpoints and the horsepower that we have on some of these endpoints, you actually can do the image analytics at the camera itself, and then what you're punting out of the camera is just a message saying, "Hey, something happened." Yeah. And so,
but you'd want the images to.
You would want them somewhere, hopefully.
Somehow.
Yeah. Ideally, you're gonna. But different solutions for different problems, different networks for different solutions. All those very, very possible. In manufacturing in particular, though, there tends to be a pretty strong reluctance to adopt new frequencies that are untested, untrusted. And that just comes back to, some of these manufacturing networks are still running on 10 meg Ethernet. They favor stability over features the overwhelming majority of the time. That's not to say that they're stuck in their ways, but if it ain't broke, don't fix it.
So, let's take this camera example. Let's say instead of doing it with just cameras and then networking it somehow, you use really cheap Android phones. Do people ever use consumer? I'm serious. You throw an LTE chip in something, and do people use consumer networks for this kind of stuff? And I'm assuming a lot of facilities won't have great connection, but if it's not low latency, high bandwidth anyways, if it's just, if it connects sometimes good enough. Yeah. Do people do that?
I've seen everything from consumer grade phones to Raspberry Pis in manufacturing environments, and
some LTE USB thing
or something. Yeah. And again, it sort of comes back to the application. It comes back to how it's built. It comes back to what the expectations are from an availability perspective. If you're telling me that you're going to deploy a Raspberry Pi in an analytics environment that has a 99.999% uptime in any given year, I'm going to laugh at you. But if you're deploying an Android tablet for doing facial recognition and temperature alerting as people are walking through the door, that's certainly a manufacturing use case, even though it's not PLC controlled. It's more safety, obviously. But yeah, if you have an Android tablet that has a 4G radio in it so that you can get telemetry out of that, where you can see who is coming, or, hey, I had a failure, I'm going to triple alert, and that's going to go to the cloud, and that cloud's going to report back something down. Not low latency applications. Those are perfectly acceptable to do if your customer is good paying yet another cell phone bill. And that's the problem, is when you deploy these phones or these SIMs or these USB modems, they have to connect to something, and that's a Verizon, AT&T, Sprint, Orange, or whomever, right? And just like we pay for our cell phones, enterprises pay for their cell phones. And if you're going to pick up...
The carriers must have bulk sales for this type of use case, do they?
They will make it sound so appealing to you that you won't even know what hit you by the time you get your first $1 million a month bill. Yeah, they'll spin you up so bad it's not even funny. Yeah.
So is that why people maybe shy away from doing things like this?
Yeah, you bet it is. On top of the fact that the CBRS for some of those applications, not unappealing. Then again, neither is Wi-Fi. You can do a lot on Wi-Fi networks. And in fact, I would wager that with a properly built Wi-Fi network, there's very little you can't do on Wi-Fi. But that's a big asterisk. It's a big asterisk. Properly designed Wi-Fi networks, properly built Wi-Fi networks, they're a rarity. Most organizations just go, hey, I think I need an AP over that away. Cool. We'll see how it goes for you.
I guess I'll do kind of a last tidbit here and leave it a little open-ended. Anything cool and interesting that I didn't call out that's happening in this space that you kind of want to highlight?
Oh gosh, no. No.
Okay, cool. I'm putting you on the spot there.
Yeah, I mean, I would say that CBRS is still, private LTE is still very much a nascent technology. Absolutely. We see enterprises trying to dip a toe into the waters that have been commonly held by carriers. enterprise IT organizations, they're not carrier management organizations. Dealing with carriers sucks. And there's a reason why carrier networks are so terrible, is because they're overly complicated and cumbersome. That's not to say that enterprises can't run an LTE network, but you don't just want to go buy an off-the-shelf Nokia private LTE system that's going to come with enhanced packet cores and texting and messaging services and voice services and phone number integration for outbound federations and all that stuff. You just want to get bits and bytes from a thing to another thing. It's that machine-to-machine communication that's so all blasted important in a manufacturing network. And just because you hear LTE doesn't mean it must be a carrier. It doesn't mean it must be voice. It doesn't mean it must be really anything. It's a build your own style of deployment. And you really want to be sensitive to things like interference, frequencies, licensing, and especially regulatory concerns.
So you would say that even though you did want to highlight that it was a false dichotomy that you go Wi-Fi or you go LTE, they are complementary and
very
have
much so.
Overlapping and dovetailing use cases.
Very much so.
Would you still say it's a fair characterization that industrial LTE solutions will take up an increasing share of the wireless communication in industrial settings?
Yes.
Or they will open up new
they'll open up new use cases, I think, is probably the better way to put it. I think that the number of devices, pick an annual report from any manufacturer, and the number of mobile devices is on a hockey stick curve, right? And it just keeps going up and to the right all the time, which means that your device explosion in manufacturing is going to be the same as its device explosion anywhere else. Your volume of Wi-Fi devices is unlikely to go down, and in fact, it's likely to continue to go up. It may not go up as fast if you're deploying some of these other complementary technologies, because that might cut into some of that adoption, but there's no slowing down the number of devices that are coming onto your network at all. No slowing it down, no stopping it.
So that as a selling point of industrial LTE is not oversold. So if you do use industrial LTE, then it does drastically increase the number of devices you can use.
Sure, it's another transport medium. You're deploying a third or a fourth network for a third or a fourth class of devices. Yeah, no doubt about it.
Right. Okay, well, super, super fascinating, and I can't thank you enough for sharing all of this with us.
Absolutely, my pleasure.
If folks want to get in touch, where's the best way to reach out?
Yeah, so I'm one of the Twitter guys. So at Samuel_Clements on Twitter. My email address is my first initial last name at gmail.com, and that's where I am, and that's what I do.
All right. Awesome. Can't thank you enough for joining and sharing all of this.
Absolutely, my pleasure. Looking forward to talking again.
All right. Have a good one.